Cool. I think we're live. Thank you so much, Lucas. Super excited to chat about everything that you're working on at Jito Labs and what you're building. I think this was one of the most requested podcast episodes. So excited to finally get to chat and kind of hear your story and all the good things that your team's working on.
Sweet. Thanks for having me.
Very cool. One thing that I think you and I have like a unique background on, just to start the conversation, was Tesla. I know you did an internship there, working on the Model X, and I would just love to kind of get your quick experience on thoughts at working at Tesla and kind of the learning lessons from that.
Um, yeah, I think there's a lot of like Silicon Valley startups look sexy from the outside and you think they have their stuff together, and then you show up and you're like, oh, this is like chaos. I think that was kind of my introduction there. Super cool place to work. Uh, Worked on the like Model X Falcon Wing doors, anything that like moves or lights up on that car. So
Yeah.
like the second row, that car was just like super fancy, way over engineered, but
Yes.
super cool. Um, yeah, I was saying earlier, like it's the biggest startup that I've worked at. Just everything's always on fire. Everyone's super moving super fast, but everyone like loved it there. They did a good job hiring people that were like super passionate, and I
Yep.
think um, that's definitely important when you're like building a startup. Find people that are super passionate and work hard.
I fully agree.
Those
Yeah,
things.
it was a unique experience for sure. You definitely learned a lot and always lots of fire drills. But no, it was interesting or
Yeah.
awesome to kind of get your perspective. Maybe to start off the conversation, I would love for you just to maybe touch a little bit more on like your background as an engineer, and then kind of your like quick journey and how you got interested in crypto and blockchain.
Yeah. So, studied computer engineering, at Carnegie Mellon. Always just kind of interested in like computers, things that like move or light up. Um, so kind of went down this like firmware and embedded systems path. So, embedded systems are like working on things like AirPods or just like small microprocessors, things like that. Um, so yeah, I guess like working at Tesla was a super cool experience. Worked on some really hard stuff, things that moves or light up, just like right up my alley. Um, Got into like consulting for a bit, so kind of like a drop-in hardware team for
Hmm.
teams that didn't know how to build hardware. Um, so writing anything from like bare metal C to working on like real-time operating systems to uh, like an Amazon Alexa type device that had voice recognition. Um, so yeah, kind of just got like exposure to a bunch of different stuff. Worked on like 10 different products in a year. Kind of just had to like learn super fast about different domains of computer science, computer engineering, anything from like programming in Python to like getting out oscilloscopes and like probing spy lines to figure out why this LED won't turn on.
Yeah.
Um, that kind of led me to this company called Built Robotics. They are trying to solve construction labor shortages through automation. So basically, the first, I think it was the second week I was there, we bought like a $300,000, 50,000 pound bulldozer.
Wow.
It's like, okay, figure out how to like hook into it and control it. So did everything from like ripping apart the cab, figure out how the joysticks work. It's like PWM, this duty cycle, uh, this frequency to like, okay, let's hook an Arduino into it and get like an Xbox controller and kind of like drive the bulldozer with my Xbox
Yeah.
controller to like sourcing sensors, hardware, writing the robotics controls for it, all that.
That's awesome.
Um,
Wild times.
yeah,
How is it driving that with an Xbox controller?
it's pretty scary, especially when you're not in the cab.
Yeah.
Uh, they took safety very seriously, so like there was several layers of safety, and we had a remote e-stop for it. But
Nice.
It's super cool to, it's like being a big kid
So how'd
when you're
you go
driving it.
from kind of a lot of more focus on the hardware aspects and kind of that front to getting more into like the software and blockchains?
Yeah, so I think I discovered crypto and blockchain in like towards the end of the 2017 cycle.
Mm-hmm.
It was like Litecoin, Verge, Bitcoin,
Yeah.
Ethereum.
Wild times back then.
Yeah, like stuff was going up like 2x in a day. I was like, oh, this is cool. It's cool until I lost all my money
Yeah.
and held it down. Um, but kind of stayed in the know, like on Twitter, um, through like 2019, 2020. Saw DeFi start to pick up. Um, got into that a little bit. The uh, the moment when I decided to switch from just being like a speculator to like a builder was I read Dan Robinson's Dark Forest article.
Yeah.
So it's talking about like Ethereum's mempool is a dark forest and kind of how they were trying to like white hat hack some funds that were lost, and there was a bot that like kind of front run them.
Yeah.
Um, it's kind of just going over like all the MEV stuff happening on Ethereum. So I was like, oh, this is super cool. Um, and I think I started like working on a MEV bot that night. Um,
Crazy.
so then, yeah, I stayed up to like worked my day job and then stay up to like 2 or 3 in the morning on this bot. And that's kind of when I got hooked into like coding on blockchains.
And was that first kind of bot implementation on Ethereum?
Yeah, I was.
And ultimately, now Jito Labs is more focused on like the Solana front. What kind of
Hmm.
learnings did you have from creating that first bot on ETH, and what ultimately kind of inspired you to like after building it that this was something that you wanted to do full time?
Yeah, so I guess the learnings, like I had mainly been in like embedded systems and robotics before that. So just like learning how to run infrastructure, how to set up this like automated trading system, how to like monitor the mempool, like what kind of strategies people are running. Um, it was just like a really good learning experience to kind of just dive into something different
Yeah.
and figure out how to make it work. Um, and then, sorry, what was the second question?
Uh, Kind of
Like
like
why?
yeah, like the learnings from like building on ETH, and maybe even like touching upon like Solidity or how that worked. And then
Yeah.
maybe after that, like I think one thing MEV more holistically is kind of a very technical topic, and a lot of people I would say are still trying to wrap their heads around it. So
Yeah.
maybe kind of just like wrap up kind of your learnings, and then go into what is MEV, why it matters. And I think I saw some of your recent tweets going back and forth with people saying MEV is gravity, and I agree. But like
Yeah.
describe kind of like that thought process as well.
Yeah. Um, so yeah, like I kind of just put together the bare minimum bot on Ethereum. I didn't really understand Solidity. It was kind of like right as Flashbots was taking off. So some of this being super, super gas efficient wasn't absolutely necessary like it is
Hmm.
today. Um, but then, yeah, I did the Solana hackathon, got into MEV through that.
Nice.
Um, or sorry, I did something completely different from MEV and then kind of saw what was happening with Flashbots, the success that they had, just reducing gas prices and like the congestion on Ethereum. Kind of saw what was happening on BSC and Polygon, and then came up with the idea for Jito Labs. Kind of had this theory that it would the same things would start to happen to Solana.
Yeah.
I think we've seen that come true. Um, and then yeah, I guess like on MEV, so MEV is maximum extractable value. I saw like yesterday there's a few other ways that people are phrasing it as well. But
Yeah.
basically, it's like your power as a block producer to insert, reorder, censor transactions to profit. Um, so on, you know, some differences on like Ethereum MEV and Solana MEV. I guess there's like a few obvious things, like Solana doesn't have a mempool.
Yeah.
Um, Basically, transactions go from your wallet to RPC server, and then it looks at the leader schedule. It's like, oh, Logan's the leader now, and then Anatoly's the next leader. So I'm going to send it to those two and uh, wait for it to confirm. The next one is like throughput and latency. Like, Solana is very fast, very low latency.
Yeah.
Slot times are 400 milliseconds, and you might be in Germany in for the current slots, and then you'll be in like New York the next, and then Miami, and you're kind of just like bouncing around the world every 1.6 seconds.
Yeah.
Um,
It is pretty impressive how quickly they've been able to, well, one, the block times, but then also on the latency front. It's very
yeah,
impressive what Solana's been able to achieve.
yeah, it's a crazy piece of engineering, especially for it's been like 2 or 3 years at this point.
Yeah.
So
Maybe uh, kind of continue on the topic of just like more holistically MEV and kind of why you wanted to specifically focus on this, like the MEV problem. And then we can talk about more the Solana MEV problem.
yeah, yeah, I wanted to focus on it because it's just like very uh I feel like it's the like an area that I feel like there's constantly more to learn in.
Yeah.
Um, I just like learning about things and especially like complex engineering things. So it's kind of just like that curiosity that got me hooked. Um, and then also like after participating in the Solana hackathon and like building something on there, um, I just realized like how much of a better experience it is than Ethereum.
Yeah.
And I wanted to uh I wanted to see that succeed. Like, and
Mhm.
I want to continue to see that succeed and like have have it so that everyone has like a good user experience
I
on
fully
there.
agree. I think, I mean, it's been interesting just kind of watching the progression of blockchains over time. And I think what now is interesting to me is getting kind of that user adoption. And I think personally to have that continue to actually grow and get people like interacting with smart contracts, you kind of have to have that Web 2 like experience because that's what people are used to, while maintaining kind of like the censorship resistant pieces and decentralization, but keeping that
Yeah.
high kind of performance. And so I'm very interested, and I really do like Solana's design just because I think they've optimized for the correct things. So it's very cool. Maybe to yeah, talk about why or like what is the state of kind of MEV on Solana, and why you've decided to focus kind of Jito Labs and the engineering efforts on MEV there.
Yeah. So the state of MEV on Solana, we have an MEV dashboard. It's on our website, jito.wtf. And there we collect stats on like what's going on in Solana. So if you look there, I think it's like over 99% of liquidation attempts fail. It's like 98 to 99% of arbitrage attempts fail. Um, During like very high volatility times, there's a significant portion of the block space that's dedicated to those transactions.
Mm-hmm.
And
And why do a majority
uh,
fail? Is that because other people are also attempting to liquidate certain things?
yeah, so it's kind of just like a spam game. Like, um, Labs is doing a lot to fix this, and I'm like extremely optimistic on Quick and fee markets to kind of fix this.
Mm-hmm.
But the fees are so cheap right now that um, there's not really a penalty for uh, failing transactions.
For sure.
Like on Ethereum, if you're trying to land an arbitrage, you basically need to cover the price of gas, which is like $50.
Yeah,
So if you're constantly failing $50, that's gonna add up very fast.
for sure.
Uh, Solana, it's like a hundredth or a thousandth of a penny,
Hmm.
whatever it is today.
Yeah.
Um, so um, yeah, that's kind of like the state of Solana. Quick is like being rolled out now. There's a lot of validators that are running Quick, and that will help kind of give some back pressure to
Hmm.
bots. So basically, if they exceed their allowed throughput, you can kind of tell them to back off or disconnect them.
Hmm.
And then I think the fee markets will help a little bit as well.
Yeah.
Um, but I think there's still this like need for very fine-grained transaction ordering that essentially like Flashbots introduced with bundles.
Hmm.
So that's kind of what we're focusing on with all the stuff that we're working on is uh, more flexibility on the transaction ordering to basically make the whole chain run more efficiently.
Very cool. Yeah, I'm very excited for the network updates as well. I think kind of the innovation of doing fees per contract versus the global fee markets is a massive one. As I've talked with other kind of layer one protocol architects, they're very interested in implementing this design as well because I mean, holistically, it just designs a much better user experience. It honestly just makes sense as you're kind of pricing resources accordingly. But very cool.
Yeah.
I think maybe one thing that we could also touch upon is why is like the no mempool important in Solana versus like, I mean, I'm not sure of any other blockchains today that do not have a mempool. What about that functionality makes it unique?
Um, so yeah, I guess it's unique in the sense that um, if your transaction doesn't like basically there's no like pool to send things to. And uh so it adds some layers where each layer is kind of responsible for potentially retrying that transaction to
Hmm.
land it. Um, I think that like a mempool would be very, very hard to build at this throughput, and it's also super inefficient, um, given how fast Solana is moving.
Yeah.
Like it wouldn't really make sense to uh, have this mempool that every node on the network has for, especially when there's a lot of transaction activity. Um, there is this it's kind of like, there's no global mempool, but you could almost view it like a rolling mempool where like RPC servers and like wallets are sending transactions to the current leader in the next three.
Hmm.
So you kind of have this like sliding window mempool, um, which seems to be like way more efficient than the global mempool.
Definitely. And was this kind of, I mean, again, the main was the main reason again for building on Solana was just kind of that user experience, or was it more just like the technical novelties that the design enabled?
I would say all of it. Like the user experience is amazing. Um, I think that it has probably the highest chance of onboarding the most people. So from that standpoint, like we want to see it succeed.
Yeah.
And obviously it's like extremely technical. Uh, we spent almost a year at this point, like building our system. So it wasn't like a trivial thing to
Yeah.
work on, which is fun for engineer like me.
Yeah, for sure.
Um,
And
and then there's also a lot of like interesting like DeFi composability that you can do on Solana that I think isn't possible in other chains.
I fully agree. Maybe to touch upon two things there. You mentioned kind of the slots and kind of like the 1.5 seconds or so of
Yeah.
like the single mempool. Could you talk upon that? And I think you did briefly about how those kind of move about worldwide and kind of those pros and cons of that, and then touch upon like the composability aspect as well.
Yeah, so the mempool or I guess the like moving mempool, um, essentially what happens like when let's say you're on like Orca or some other Solana dApp, you do your interaction, you sign the transaction. That transaction is then sent to an RPC server. That RPC server is like keeping track of time. So
Mm.
it knows what the current slot is. It knows the leader schedule. So essentially what happens is it looks at the leader schedule and the current time. It's like, okay, who are the next 3 validators or who are the next 4 validators? And it sends that transaction to those 4 validators. So those 4 validators, the current one will attempt to process it. If it doesn't, the second one will attempt to process it, and so on. You also have the validators are like forwarding. If it doesn't process those transactions, it'll forward them to the next validator in line.
Mm-hmm.
So between all that, like you get pretty high reliability on transaction being included. So yeah, I think that is like way more efficient than, you're only sending to like 4 validators or however many the kind of look ahead is.
Mm-hmm.
So it's way more efficient than sending it to like every single validator on the network.
Yeah. No, it's very clever. Anatoly ultimately wrote I think 8 Medium posts about kind of the key innovations of Solana's design. And I've read all of them multiple times, and every time I go back and reread them, I feel like I learned something new and just how clever the engineering actually was. So it's very cool to hear them in your words. And then kind of, I think one of the other novel aspects just about Solana, and then we can kind of touch upon like some of the things that make it a little bit more, or get into a little bit more of the technical stuff, and then kind of go into how Jito Labs is kind of ultimately working within that. Is the composability aspect and all the unique things that kind of building on a single shard with high throughput and low latency enables. So in your words, could you kind of talk about what composability is in your eyes and how you're kind of thinking about it?
Yeah. Composability is just like the interactions between different DeFi protocols and how you can essentially build on top of them to uh, do like complex things or potentially simple things from the user standpoint, but there's a lot going on behind the scenes that is kind of abstracted away. I think another unique thing about Solana is um, the transaction format and how transactions have multiple instructions inside of them.
Mm-hmm.
And so like you can imagine like on Ethereum, if you want to compose transactions, you have to uh there's you potentially have to like write a lot of on-chain code to compose those things.
Yeah.
So you have like your main function that you're calling, and then it kind of calls into like multiple protocols as it's being executed. On Solana, like you can just pull that out into instructions
Mm-hmm.
and do it in your transaction. So it's like kind of like each transaction is like kind of like a bundle, like a bundle in a sense, where you kind of have these things that are being executed sequentially. Um, I think the cool thing about that is uh, if you're an application developer, like you don't really have to write any code on chain to do anything. Like
To take
you're kind of
advantage of the
just
composability.
yeah, like you're kind of just calling instructions, like swapping something on Orca to like depositing in Mango. Like you don't really have to write any on-chain code to do that. Like you're
Yeah.
kind of just building a list of instructions. Um,
Yeah.
I think
No,
that's super cool.
I agree. I'm personally extremely excited kind of for the single shard architecture I think a couple other blockchains will eventually do it as well, but just all the unique things that composability ultimately will enable. I think today we're still in the very early days and like exploring those primitives. But
Yeah.
as kind of like these applications continue to mature over time, how they start to compose within each other, I think will be fascinating and really kind of the secret sauce that holds the network together.
Yeah, definitely. I think the whole like L2 and cross-chain experience, uh, I think it's going to be like today, I think it's pretty hard for a user to figure that out.
Yeah,
I'm optimistic. There's a ton of smart people working in that space, and hopefully they abstract it away from the user. Um, but I think from like a user standpoint, if everything's just on the same chain, it's like way easier to think about.
definitely.
Um,
I fully
and
agree.
then way easier to compose, like you said.
Definitely. Awesome. Maybe just to touch on a couple other of kind of Solana's innovations, and then we'll jump into Jito is Turbine, kind of like how they stream blocks. What are your thoughts on like each of those from the technology perspective and what they enable?
Yeah, so um, Turbine is like Solana's block propagation. It The way of thinking about it is uh Ethereum will essentially emits in every blockchain that I know of, essentially emits the entire block at the end of the slot.
Mm-hmm.
Solana, it's like constantly streaming blocks out. And they call them shreds. So essentially you have this like pipeline where it's like you receive the transaction, it does signature verification, like deduplicates it, executes it, adds it to proof of history, and then basically breaks it up into packet sized chunks and then sends it out to the rest of the network.
Mm-hmm.
And this is like constantly going on. Um, so like the really cool thing is that like other validators will start replaying that slot like they'll start replaying that slot midstream.
Yeah.
So like, if you're a leader right now, you're streaming out slot 100, I can be like a few like tens to 100 or 200 milliseconds behind you in the same slot.
Yeah.
So I'm not waiting for the very end to like replay everything. Um,
Yeah, Turbine I think is fascinating, and the only blockchain today that I know of that is doing kind of unique data propagation outside of the gossip protocol, and I've been
yeah,
trying to find like other blockchains that do something similar, and it's just been hard to do that. But I think it's super unique, kind of piggybacking off what is the protocol that it's based on, uh, BitTorrent. Um,
uh, I'm not sure.
I think it's BitTorrent and just like how they seed information, but the fact that they're able to continuously stream data like just gets me super excited. The fact that like there are no pauses, every block is streamed in real time, and that's just a continuous process. Just
Yeah,
seems like how ultimately going forward these systems should be designed, and there's never like a pause in between things. It's just continuous data and
yep.
validation going forward.
Yeah, it's pretty crazy when you think about that, and then the
Yeah.
fact that uh, you might be in like Frankfurt 1 second, and then you're in Tokyo, and then New York,
Yeah.
like all within the span of like 5 seconds, and it's just this like never-ending stream of stuff. It's
Hmm.
super cool.
Definitely. And how does that kind of affect like rolling back state for different bundles, um, and or
Yeah.
like blocks more holistically?
So yeah, we're focused mainly on rolling back state for bundles. Um, so
And can you
uh,
also just like describe bundles as well? I think you did, but maybe like
yeah.
a little bit deeper.
So yeah, bundles are a list of it's like a set of transactions that you want to execute sequentially, atomically. So sequentially meaning like in order, atomically meaning like all or nothing, and they only get committed if they all succeed.
Hmm.
So if we run into at least the current state, we can change that in the future, but that's the way that things are currently coded. So essentially, if you have three transactions and the second one fails, it will just roll back the entire thing and uh, finish executing. So some good use cases for bundles, like um, if you're using Orca or some other DApp on Solana and you run into the transaction limit,
Mm-hmm.
the user experience kind of like leaves something to like there's room for improvement on that user experience. So by using bundles, you could essentially sign both transactions and send them through our system to a Jito Solana validator. And that validator will just execute those in a row and commit them
Interesting.
to proof of history. So that's like one good use case. A good use case for like searchers is like atomic arbitrage.
Mm-hmm.
So,
And what
you
are the
know,
searchers doing?
for when they're like building bundles
Okay. So
or,
I'm just asking, like, more holistically, like, what is a searcher? What is its role? What is it
oh,
application?
yeah.
I think a lot of people are like super interested in MEV, and obviously, I
Yeah.
mean, you guys have thought extremely hard about this and have spent a long time like setting up the engineering process. But maybe like even like backing up further
Yeah.
on like what is like the like maybe step by step of like what's happening in Jito Labs, from like the technology perspective, just so people can like follow along with like your thought stream.
Yeah. So I guess I'll start at the top. So MEV searcher is essentially someone that's searching for these opportunities to make money. So that can be like arbitrage, liquidations, um, minting NFTs, whatever it may be, where they
Mm-hmm.
think that they can make money. Um, and I think that they're like extremely critical for blockchains to function, like these high frequency traders. They keep all the prices in line, make sure that protocols are solvent and all that stuff.
Mm-hmm.
So right now in Solana, we kind of went over this earlier. It's kind of like there's like a latency race. So basically, you have validators that are like sharing their Turbine streams with RPC servers, kind of like skipping multiple hops to get low latency access. And people are like tuning their RPC servers to make them run faster. And it's basically like who can get processed first. This results in like a lot of wasted block space that we talked about earlier. So essentially, what we're trying to do at Jito is build more efficient infrastructure to kind of enable MEV,
Mm-hmm.
like more efficient, make it happen more efficiently, make the network run smoother, help it scale, and then also it's super important that MEV is distributed to stakers as well. So we've built all that infrastructure too.
Awesome. Maybe going a little bit deeper into that, how does MEV more holistically help like increase the performance of the network? I think one aspect that's unique is like it's basically incentivizing node operators to upgrade their requirements to
Mm-hmm.
kind of help process more transaction and more throughput. But I'd be curious, in your words, how does it make the network better, and why do you describe
Yeah.
it like gravity?
uh, yeah, I described it like gravity because it's like inherent, like you can't get rid of MEV in
Mm-hmm.
distributed systems like blockchains. It's just kind of like a property that exists, and um, yeah, you just can't like. I know Kyle was kind of shit posting there, but I was shit posting back at him.
Yep.
It's like you can't really get rid of gravity.
Yeah.
Like you can't really get rid of MEV. Um, I think, MEV, it's important to like, I think it's important for like dApps to minimize the MEV that they expose their users to. It's like, when you go on Uniswap, you set your slippage too high or Orca, it's like you might get front run. Like there needs to be a lot of that happening on front ends for people that don't necessarily know what MEV is,
Mm-hmm.
just so that they have a good user experience. But everything else, like, MEV is impossible to get rid of. So for everything else, like we should efficiently extract it.
Mm-hmm.
And I think it needs to be distributed to stakers. I think it's a good way to encourage more people to stake and secure the network. And then it also um, provides like a little extra revenue to validator operators. So it has the potential, like you said, for them to potentially have more money to upgrade their hardware so that they can process more transactions um, to like bringing more validators online as
Hmm.
well. Um, so if you're making a little extra more money, you need less stake to break even. You can spend more money on your operations.
Yeah, it totally makes sense. And I
Mhm.
like the point of view of being able to distribute that back to stakers. I think
Yeah.
if you are able to optimize something and other people are able to contribute to kind of that vision, everybody is kind of aligned and incentivized to push that forward while making the
Mhm.
network healthier. Pretty cool idea.
Yeah, that's like super important to us. These users are helping secure the chain, and they're all also like users of the chain, and um, like we believe that that should be distributed to them.
For sure.
And um, I think that they will use it to like stake more Solana as well,
Definitely.
which increases the security and decentralization of the network.
For sure. And one thing that you mentioned was kind of today, because the network doesn't have fees by contract, um, some of the block space can just get flooded. Fees per contract will ultimately get implemented on Solana. Hopefully, that reduces some of the spam. I think we both are aligned on that. But how does MEV specifically kind of use block space more efficiently? Because block space, I think, more broadly on every blockchain is kind of that scarce or valuable resource. How
Yeah.
does MEV plan to use it more efficiently?
Yeah, I guess like the I guess MEV will always be there. It's just about how do you capture it and how efficient is that process. So, right now it's kind of this like game where uh you see an update, I see an update 10 milliseconds later, and so on. And all these people kind of just send transactions. They all get there at different times, and that's kind of how you end up with this wasted block space. Um, Ultimately, I think it's because there's like this aspect of like probabilistic ordering
Mm-hmm.
where you don't necessarily know if you're first to respond or not. And you know the ordering you want. Like I want to, if I see some opportunity to create an arbitrage, I want to be directly behind that. So the system that we built with like bundles in our block engine lets high frequency traders and searchers be very granular about what ordering they want.
Mm-hmm.
And we will kind of take care of the simulation, making sure that people are paying the most for some set of state and only sending things that succeed. So like right now, you might see an arbitrage, and then like 100 milliseconds later, you see a ton of packets come through that once the first one succeeds, off the rest fail.
Yeah.
We're offering like a essentially guaranteed ordering and atomic ordering as well. So you can see that packet come through, submit a bundle with that arbitrage, and um, we'll essentially like make sure that it pays the most and submit that one to the validator, and then the rest won't make it to the chain.
Very interesting.
So there should be like one transaction that creates arbitrage, one that captures it, and
Mm-hmm.
then that's like the most efficient version.
Awesome. Well, maybe that's kind of a good off point into kind of what you're more building at Jito Labs and some of the products you're offering. So, could
Yeah.
we go into kind of what you're working on at Jito and some of the things that you're excited about today?
Yeah. Yeah, we've been super busy, so uh excited to kind of talk more about some of this stuff.
Yeah.
Um so yeah, we have I guess our big thing is like Jito Solana. So this is a fork of Solana Labs validator client.
Mm-hmm.
Um and that unlocks a few things. It unlocks transaction bundles that we were talking about earlier. Um it unlocks there's like some MEV tip payment and tip distribution code in there, which I can get to in a bit. And then it also unlocks connections to like relayers, which I'll get into in a sec as well.
Cool.
So Yeah, we've added a few thousand lines of code. We have like our own transaction execution pipeline that allows you to like execute these things and potentially roll back state. And then we also like change proof of history so that you can essentially batch write bundles to proof of history. So you
Interesting.
can imagine a situation where like you're at the very, very end of your slot, you have like five things to write, and you only have enough time to write four of those. You don't want to commit the first four and like leave the fifth one out. Like you just want to drop the entire thing. So we
Yep.
kind of have all that stuff to make sure that the entire thing is shared with the rest of the network. So the rest of the network doesn't even know that stuff's being rolled back. It's just being handled internally.
Very, very cool. So is this going to be the third client on Solana? The Solana
Yes.
client, Fire
Yeah.
Dancer, and
Yeah.
Jito Solana.
Yep.
Very cool.
Yeah.
That's
Yeah. We're
awesome,
super
man.
excited. Yeah.
I think
Um,
hopefully between all three of those, we'll have less downtime going forward.
yeah, I hope so. Um, so yeah, that's kind of like been our baby for the past like few months. We've gotten an audit and then we're just doing another like double check audit right
Hmm.
now. So we should be releasing that very, very soon.
Awesome.
We just want to
Congrats.
make sure that, you know, it's very scary to release something like that. And
Yep.
uh, Solana is like very complex technically. So we want to make sure that we release it and we're very, very comfortable about the reliability of it.
Hmm.
Um, So yeah, that's Jito Solana. We also have a relayer. The relayer will essentially work with Jito Solana, so you can run. It's essentially like a TPU proxy.
Okay.
TPU is transaction processing unit. So validators gossip out, hey, like here's my IP, here's my port, here's where you send transactions to, um, and when there's a lot of volatility or a lot of MEV going on, they kind of just get slammed with packets.
Hmm.
So we essentially added this relayer where you can run it on a different server, and it works with UDP and the quick that's being rolled out. It runs the filtering, sig verify, all that stuff, um, and then it will forward those packets to the validator. So it's kind of like um, it's just like a proxy that does some filtering and things, but it
Hmm.
also plays a core piece of our block engine and the like the mempool stream that we have. So
And maybe
essentially,
for the
oh,
vast
go ahead.
majority of people, could you also just explain like what a relayer is and what it does?
Yeah, so I guess this relayer is like a little bit different than the Flashbots relayer.
Hmm.
Um, but you can think of it like a proxy. So essentially, we're putting the relayer in front of the validator. And instead of the validator receiving those packets first, the relayer does.
I see.
So the relayer, it lets you run the same algorithms on the validator to kind of filter packets and things like that and deal with all potential like spam and stuff like that to a different server.
Gotcha.
Um, so yeah, and it also plays a core piece of our block engine as well. So um, packets will essentially hit the relayer. Uh, they get forwarded to the block engine,
Hmm.
and the relayer keeps those packets in there for super short amount of time, like less than a blink of an eye. Um, and that time is how much time searchers have to submit bundles and give our system the time it needs to like figure out what's the most profitable bundles to submit. And then after that short amount of time, the relayer automatically forwards it to the validator. So this is like a very censorship resistant way to design the system. Like we, like us and any future people that use the system will not be able to censor transactions. So it's just kind of like removing that whole uh, potential area of like FUD and even the ability to like do that as well.
Interesting. Very cool. And the block builder is kind of what you ultimately submit as your bundle to um, to kind of the leader node and trying to get that included to be validated by the rest of the network.
Yeah. So the block engine is like it's like the interface between validators and searchers. So searchers can connect there. You can subscribe to pending transactions there, and transactions that the relayer send over are forwarded to searchers. Searchers can then bundle stuff up, submit bundle. Uh, we do like a ton of simulation.
Mm-hmm.
So basically trying to, we run a bunch, and we also run like a bunch of parallel state auctions as well. So, because of the Solana transaction format, the read and write locks
Yep.
that a transaction holds. So you can actually run these auctions in parallel.
Interesting.
So like, someone's trading on Sol USDC on Orca can be executed at the same time. Like there's no dependencies between that and like BTC USDC on Orca.
Yeah.
So we can like basically kind of split up all these auctions and run them in parallel and simulate to figure out who pays the most for some given set of state.
Very cool.
And that's a very hard problem because we're also trying to simulate. We're doing all that, and the stream thing that I was talking about is like the the shreds are constantly being streamed, and the RPC servers are constantly trying to replay and like be as close to the tip of the network as possible.
Mm-hmm.
And we're trying to simulate on that state. So it's a very, very hard problem to work on.
I bet. Yeah. I'm super curious just over the long term too, how the hardware continues to progress as more data gets submitted to nodes. So it's definitely a hard engineering problem, but I appreciate what the Jito Labs team is doing to be at the forefront of that. And again, just super excited by what you're doing with the Jito client. That's super exciting.
Thanks. Yeah, we've worked a lot on it, and a lot of those changes, like we want to get it into upstream as well.
Mm-hmm.
It's like some of the replay stuff that I was working on like a few weeks ago. We want to get that into Solana Labs client because that will just massively like increase the throughput of those validators. So we're definitely like extremely dedicated to our own client, but also like getting things into Labs client as well.
Contributing back to the ecosystem.
Yeah, for sure.
Awesome. No, it's very exciting work, and I think a lot of people are fascinated by what you and the team are doing at Jito Labs, and ultimately how it will help benefit the network, and eventually, I mean, even with distributed staking, how they'll kind of earn money from what you've been building there as well. So out of those like core 3 products, is there like any one specifically that the team is like focusing more on holistically, or are they all kind of pretty intertwined with the client, with the relayer and the block engine?
Yeah, I'd say most stuff is working on the block engine and just like infra around that.
Mm-hmm.
So everything's running on bare metal. So there's like some unique challenges there. Adding features to the block engine and kind of just like being able to like fluidly move from one thing to the other and figure out what the bottlenecks are and fix it.
And when you say bare metal, what does that mean for the people watching?
Yeah. Run your infra on bare metal, especially if it's Solana. You'll see Totally talk about that a lot. Bare metal is basically like you're not running on top of a virtual machine or any like virtualized environment. Like you are running on like Ubuntu that's running on the metal itself.
And the reasons for not running on the virtual machine and just running on the actual hardware itself is just extra performance increases, correct?
Yeah. Yeah, it's like extra performance increases, and sometimes when you run on like VMs, you can run into situations where like you're sharing it with like could be sharing a VM with like Google, and they're just like abusing it and kind of like taking away compute from your the VM that you're running on, because you're like sharing the RAM and all the memory and SSDs with other people. So By running on bare metal, it's like only you, no virtualization.
And I'm curious on like what hardware you guys are running today to do all the like keeping at the tip of the network, and then as we continue, I'd say to onboard more users, where do you kind of see that progressing over time?
Yeah. So we're in the process of moving to like the third gen AMD chips.
Mm-hmm.
Um, so we found a good provider that has that. Um, and those run way faster.
Nice.
Um, so that will be pretty cool for just our entire system, our
Mm-hmm.
validators, our RPC servers, block engine. Um, as the network onboards more people, like you're gonna start to see, I think Fire Dancer and like the jump team, this is like their kind of like bread and butter. Like,
Yeah.
if you look at the Fire Dancer repo, it's like, what is this? Like, it's super, super low level. It's like kind of reminding me like of embedded systems I used to work on where you are like working very close to the metal. Like, so I think you're gonna like continue to see that. And then you're also gonna continue to see uh people upgrade their servers to maybe the newest gen processors. There's definitely a future where things go to like FPGAs,
Mm-hmm.
more stuff running on GPUs, just these like dedicated programmable circuits that have one purpose and they do one thing very, very well.
Yeah. I asked Totally this question as well to get his thoughts. He said he was unsure about like FPGAs, and he said maybe GPUs, but he was like, he thinks ultimately they'll kind of satisfy all the population with like a 512 core. He said 256, but potentially 512. And so,
Okay.
what are the AMD core counts today, or the new ones that you guys are going to be working with?
Um, I think they're like 32 core,
32.
64 thread.
Okay. Interesting.
Um, yeah, I guess you could most people are running on like single core motherboards,
Mm-hmm.
but they do have like dual core or even like quad core motherboards that you can get. The issue with those is the clock speeds are usually slower, so they
Yeah.
can't keep up with proof of history. But there's certainly a world where uh, I think I could buy that if there might not be like the absolute need to run on FPGAs,
Mm-hmm.
but
I,
something needs to change to
y-
get there.
yeah.
Software and hardware.
Yeah. I definitely I think one of the biggest misconceptions that I see is that like Moore's law is kind of dead. I think in some sense it's true with like the clock speeds, but ultimately by adding additional cores, you still get kind of the extra performance increase. So I'm very excited to watch kind of the hardware progress, but also the software, what you're building, what
Yeah.
Fire Dancer's building to kind of take advantage of those additional cores. So it'll be fun to watch.
Yeah. Yeah,
Um,
the Fire Dancer team's doing really cool work with uh just like, they're very, very close to the metal.
yeah.
So
To
it'll
me,
be
it's
cool to see.
surprising. Just, I mean, their goal of 10 gigabytes per second is just so more ambitious than I would say like any other of kind of more the legacy blockchain architectures like Ethereum. That to me, it's just like a totally different world. But I'm excited that someone's trying to do something
Yeah.
as ambitious as that.
Yeah, I think there's a lot of people that just kind of like wave their hands and they're like, "Oh,
Yeah,
we need scaling,"
yeah,
but or like L2s and stuff like that. But I feel like we haven't hit the limit of what hardware can do.
exactly.
Um, I mean, yeah, I think there's a lot more to squeeze out from there before I would feel comfortable saying that we need to do this stuff.
I
But
fully agree. Um, yeah, no, the limits we're not even close. I would say we're just scratching the
yeah,
surface, and so it's cool to have some blockchains attempts to find those limits. But very cool. Maybe touching a little bit more on kind of the MEV distribution, like the tip payment, and how you guys plan to distribute kind of the MEV earnings by the software that you've developed?
Yeah. Super good question. This is like the thing that I think uh, a lot of stuff we talked about is like pretty technical, and
Mm-hmm.
maybe the average user cares or they don't. But I think the people really care about this.
Yeah.
Um, so yeah, we have these two on-chain programs. We call it like tip payment, tip distribution. Tip payment lets you tip validators for like essentially priority access to like transaction processing.
Mm-hmm.
So there's 8 accounts that you can tip. Uh, we did 8 so that you can like potentially multi-thread or have multiple bundles executing in parallel that touch that state.
Mm-hmm.
Um, and essentially what happens is people tip those 8 accounts. Uh, when the validator is done processing when the validator is done with their slots, they transfer the money from there to this MEV or tip distribution program. And every validator has their own tip distribution account per epoch. So like you'll have one for epoch 100, 101. I'll have my own for 100, 101. So
Mm-hmm.
essentially like splits up the validator's MEV profits per epoch into the single account. So then from there we have code running and we'll open source this that takes a snapshot of everything at the end of every epoch.
Yeah.
So very last slot in the epoch, it will take a snapshot of all the stake accounts, and then we essentially generate like an airdrop for the software will generate an airdrop for each stake account that contains MEV. So if you're staking to a validator running Jito Solana, you will get an airdrop every epoch that contains your pro rata share of MEV on that validator.
Nice.
The validator can take commission. So we have like a open commission percentage that they can set. So you can kind of see what other validators are taking and make stake decisions on that. And then the validator can like upload their own airdrop or they can delegate it to others. So
Very
like we'll
interesting.
be running this code. If they want to do it themselves or they don't trust someone to do it, they can do it themselves. And
I'm
we
curious.
tried to like design this in a way so that the validators like don't have to touch the money at all.
I'm curious over the long term, with this additional benefit and kind of money that you're returning to the people. What percentage of like market share do you think you'll get to with like Jito Solana, just as validators kind of opting in for this additional kind of attribute that you're providing?
Yeah. I mean, I hope 100%. Um,
That'd be pretty wild.
yeah. That would be pretty cool. But I think that like
So,
these systems will work with Firedancer.
okay, that
They'll
was my
work with
next question.
like we can port this into Labs Validator
Mm-hmm.
and like pull out the critical pieces of our system, like the connections to relayers and block engines and stuff like that. So there's no reason that like it just has to be our client running it. We're kind of just like a added layer on top. So
Makes sense.
um,
Very cool.
hopefully Firedancer will use this. And yeah, hopefully we get to like most of the network running it because I think that there's a really good article by someone at Reciprocal Ventures. It's called MPSV. It's like
Mm-hmm.
MEV profit sharing validators, and I think we definitely like buy into that thesis that there's going to be competition for validators that share the most MEV. You're kind of seeing this with validators like running with zero commission, or
Yeah.
some are like modifying the voting code to get better voting performance, so they show up at the top
Mm-hmm.
for like they're earning more money for their stakers. And I think that you're going to see this with MEV too.
So you think that's kind of like the end goal for node software in like return in terms of like providing back that value
Yeah.
to to the stakers.
Yeah, exactly.
Nice.
I think it's really healthy for the network too.
Yeah.
Um,
No, it's very exciting. Lots of cool
yeah.
things that you and your team are working on. I mean, obviously it's super technical, but I'm glad that you guys are doing it. It's definitely much needed, and I think ultimately healthy for the network, healthy for the users, and just being able to align all those incentives to kind of push the space forward is fabulous. I know you guys are pretty focused on Solana today. I think taking kind of the more pinpointed view on doing like a single chain is unique in the space versus like a lot of applications are trying to do multi-chain. Do you guys have plans ultimately to explore different chains, or are you guys just going to double down with Solana because of its unique attributes and high probability of scaling?
We're definitely like 100% focused on Solana for now and the foreseeable future.
Mm-hmm.
There's a lot of work to do on Solana. We love like the community and the Solana team, and
Nice. We do
we
as
want
well.
to see we want to see the network succeed. Um, I do think that there's like I think we will expand to other chains at some point in like the far future.
Mm-hmm.
It's not super clear to me what those chains are
Yeah,
and how long it will take. I think it's just kind of inevitable that we do it. Um, but like we have to stay focused on Solana right now.
definitely.
And so that's the main focus for at least the next several months or years.
Totally makes sense. And then what would be kind of your advice to, say, people building applications on top of Solana or just other kind of comments on if people want to learn more about MEV more holistically?
Um, yeah, I guess my advice would be like, please take MEV seriously. Um, I think that, how do I say this? Like, I think there's room for improvement on like taking MEV seriously on Solana
Mm-hmm.
across dApps. Um, so like, please be careful about the way that you design things and like keep it in mind when you first start. Like we're seeing this with like teams like Drift and there's other teams that are reaching out to us that are like, hey, is this like sound? Is this a sound mechanism? Is this like exploitable by validators or MEV or whatnot?
Mm-hmm.
So I'd definitely say like, please be aware of that.
Is there
Um,
any way for kind of the Jito Labs team to abstract those MEV complexities from like the application engineers, or is it something that application engineers in your mind will just always have to kind of be thinking about in the back of their head?
we're certainly like kind of researching areas on how we can help,
Mm-hmm.
but we can only do so much. Like, you know, validators can do whatever they want, and I guess searchers can as well.
Mm-hmm.
I think the best way to prevent MEV is like through like sound application design, and like when that user signs that transaction, like make sure that they are not signing something that's going to expose them to unnecessary MEV.
Yeah.
It's like the front run example that I mentioned earlier, where Orca, if you put your slippage like 10%, it's like, hey, you might get front run. Like
Yeah.
that's like the perfect example. Like, you
I
know,
see. Just designing applications to kind of limit or prevent that as much as possible.
yeah. And like you're starting to see applications do that better, like Jupyter aggregators. Like aggregators are amazing for reducing
Mm-hmm.
MEV. Things like dflow are
Yeah.
also great
Yeah.
for reducing MEV.
Awesome. Cool. Well, I think we kind of hit on a long list of things, but is there anything specifically that we did not cover that you kind of wanted to talk about, or anything that I miss?
um, I guess one thing like uh, it's kind of like a little sneak peek, but I guess when we started this company, we were like thinking about like what an MEV DAO would look like.
Mm-hmm.
So Stay tuned for more news on that
Nice.
coming in the next few weeks.
Perfect. Looking forward to it.
Yeah, there's been some like really cool work that has been going on that front. So
Nice. Awesome.
keep an eye out
Well,
for that.
I everybody will definitely keep their eyes out for the MEV DAO, all the awesome things that will come with that. But no, really, just appreciate your time again, Lucas. Awesome to be able to break down some of these more complex topics with MEV, but ultimately, what user benefits those provide. And I think I mean, along with kind of just making the network more efficient, but by also kind of how it incentivizes people to update their nodes, and then ultimately being able to return some of that capital back to stakers and that MEV that you do capture. It's really fascinating and very exciting to follow along with. So thank you again for your time, and it was a pleasure.